Hi colleagues, here we are in the second video about the ASON network. ASON network component contains the ASON domain, TE-link, ASON node, SPC or soft permanent connection. TE-link represents the bandwidth between two nodes. For each link of fiber, we have a certain bandwidth according to the line card inserted in each node from A to Z node. TE-link also has its own weight. According to this weight and this bandwidth, the control plane will take the decision to decide the traffic route or decide the direction of switching. The ASON node itself has its own configuration. Exploit the GMPLS, maybe it called GMPLS or GMPLS routing engine. Of course, for connection from node A and node Z, we should create a soft permanent connection. Soft permanent connection is the connection between the permanent connection to customer A and permanent connection to customer Z. In between, we have switched connection. This switched connection created using the GMPLS protocol controlled by control plane represented in the previous video. Generally, the IPMPLS essentially created to manage the traffic over IP network, but here using a customized version of MPLS called GMPLS or Generalized Multi-Protocol Label Switching to manage the TDM network like SDH or currently OTN and DWDM network. To complete the principle, should know what is the kind of LSP. LSP may be regarded as a tunnel. This tunnel contains multiple services or multiple pseudo-wired connections from A to Z, and essentially the label switched path created using RSVP protocol or resource reservation protocol, the signaling protocol used by control plane to create or reroute the services from direction to another direction according to the impacted link or impacted network node. For each ASON node, we should implement ASON ID is a unique ID configured like IP version 4 to represent the ID of the node inside the ASON domain. We have two IPs for the network, the loopback IP and the ASON ID for each node. Also should mention here, after configuring the ASON ID, we cannot roll back this operation or this process again after configuring the all network IDs. It will be difficult after that to change this ID and roll back again. So should be careful from the scratch and set your right plan to identify all ASON IDs for each node inside the ASON domain. The TA link, of course, representing the bandwidth, and maybe we have different TA links between the different nodes inside the same network depending on the number of connections or physical connections between these two nodes. SRG or shared risk group, if the TA link is sharing the same media or affected by the same impact here, it will be named as a shared risk group and identified inside the ASON network. After identification of the different SRGs like SRG1 and SRG2 and so on, the system trying to reroute the traffic on a different SRG not impacted by the existing incident, that affecting multiple TEs sharing the same SRG. As shown here, very different TE links inside the same shared risk group. So to identify the redundant, should avoid the same name of the SRG. GMRE, as discussed, is the GMPLS routing engine installed on the node controller or system controller located in control plane to take the decision of routing and start the ASON functionality. There is a centralized ASON and distributed ASON. For centralized ASON, the ASON installed on a centralized server for each node should be communicate with the server. If this communication go down, the ASON functionality will not start it. But for distributed one, the GMPLS installed on the controller for each node, and each node contains its brain to decide the right way of protection. So the controller will have NE software, MIB, and ASON functionality. The ASON itself, or GMPLS, utilize three main protocols to handle the ASON function. The first one, OSPF. OSPF, Open Shortest Path First, is a routing protocol used to identify the network topology, including its link and including the different nodes inside this network. And each ASON node will have a routing table contains all the information about this network. RSVP, Resource Reservation Protocol. This protocol is a signaling protocol to reroute the traffic and to create the service from scratch. Link Management Protocol used to create the TE link between the different nodes and also maintain the control channels. Control channels are passing through the DCC channels starting from D4 to D12. If it is an embedded channel, and maybe going through Ethernet network, if it is going in outbound network like DCN network. The remaining part here is regarded as a part of transport network. The transport network including the line card, cross connection card, and the physical hardware inside this node, and also the fiber optic between the different nodes for constructing the network. Finally, we will have a complete ASON domain, the management plane, control plane, and transport plane, all of them constructing the ASON function over the transport network. The beauty of ASON, it is providing different SLA types according to the requirement of the customer. For example, we can provide diamond service, silver service, copper service, and also iron service or gold. But from the Huawei perspective, in DWDM network, we have just only 3 types of quantity of services, as well as, according to Huawei, the diamond classified into 3 types of quality of services. The first one, permanent one. Second one, rerouting. Third one, non-rerouting. For the permanent one, we have one main link and backup pre-calculated route. If the first one go down, it will be switched to the backup calculated link, and during this process, a new calculated route will be calculated here to be a third backup link, and so on according to the network topology and the availability of fiber link between the different nodes. In rerouting one, there is a main link and backup link. When the main link affected, it will be switched to the backup one, but there is no calculation for third one. When this backup one go down, a third one will be calculated. During this process, it will take some seconds to establish the new link and calculate the protection route, also according to the availability of the physical media. The third type, non-rerouting, we have main one and backup one. If the main one go down, it will switch it to the backup one. If the backup one go down, it will not switch anymore to a third route. Server service, we have a main route, but there is no preset route or pre-calculated backup route at this time. If this one is go down, it will calculate another route here. If the backup route go down, it will calculate third route, and so on according to the availability of the bandwidth and fiber. The copper service, it is not protected anymore. I have one link. If this link go down, it will not be routed again to any other route. It is regarded as an extra traffic like MSP ring alt scheme. We can utilize the extra traffic, but we cannot confirm its availability. This slide contains already described diamond SLA categories, including permanent, rerouting, and non-rerouting. Nokia also has the same different SLAs, but with different naming. There is a source-based restoration. Source-based restoration is like silver in Huawei, and the guaranteed restoration, it is similar to permanent restoration in Huawei. Protection and restoration combined is a kind of SNCB and SBR together. If the main link go down, it will switch directly to the backup one. If the backup one is go down, it will try to reroute this backup one to another route. It is regarded as a rerouting diamond in Huawei. Also, the ASON itself can be categorized into two types of ASON. There is an electrical ASON and optical ASON. The electrical ASON, it is configured over the ODUK level for OTN network and utilize the OTN multiplexer switching or cross connection card to switch the traffic from direction to another one. The optical ASON implemented over the OCH and commonly used for SBR. Again, to represent the difference between the different type of SLAs, we have SBR or silver. We have one route. If this route affected due to a cut or incident in this physical connection, it will try to calculate another route within some seconds. The second type, already we have one direction here and preset route here. If this one is go down, it will switch directly to the second one and try to calculate a protection route again for the impacted service to be ready. If this one also go down, it will switch it here and try to calculate a third route. And this one is called granted restoration or diamond. Third one, or PRC, or protection rerouting combined, also called in Huawei rerouting diamond. This one has a main route and a preset backup route. If this one go down, it will switch here, but it will not calculate any third backup route. When the backup route go down, it will try to calculate the third one within some seconds. Finally, the permanent non-rerouting, it is acting like SMCB service. We just have one main route and backup preset route. If the main backup route go down, it will switch to the preset route, but it will not calculate any route after that, regardless this one go down or regardless this one go up. It is not impacting the system. It will just provide two routes for the customer service. Over here we have finished today. Thank you for watching that and goodbye.